Hey, good evening, everyone. Today, we explore some new types of linear programming problems. Again, this is the way that you learn linear programming is try exposing yourself to new types of problems. So hopefully later, when you see a similar problem, these problems gets much more easier. Okay, let me read the problem. There are 200 cars at Newark and 300 cars at Jacksonville or Jayville that are required at different locations as shown in the picture. The minus sign at Newark and Jayville indicates that the cars leave from here and no car is required at these locations. The number of cars required at each location is given in the picture with the plus sign. An arrow indicates the direction of path that can be accepted. Unit cost to transfer a car is also given. The objective is to find the number of cars to be transferred from each path so that the overall cost is minimal. So as you see here, we have two supply points of Jayville and Newark. Each has 300 cars. I'm sorry, Jayville has 300 cars, Newark has 200. The other destination has some demand, so we showed it the plus sign, like Richmond, Atlanta, Columbus, Mobile, Boston. So it's somehow, let's say, you can consider as an enterprise company or other rental companies. There's too many cars piled up in two locations. They want to just return them back to where they come from, or return to the demand points that maybe there's an airport or other places that they need some extra cars. I give you like a couple of minutes to think about the problem, then I go to the solution. So some cities has double direction. So for example, it means you can send extra cars to Atlanta and send some extra to Mobile. Or you can send too many Mobile, then just send the surplus to Atlanta. But for example, some points like Newark and Jayville, they just send up. They don't receive anything. Or Richmond just receives cars. It cannot send extra cars to somewhere else. Clear question? No. Okay. So what do you think? What are the decision variables? The number of trucks that you send on each link. So, huh? Yeah, you're almost right. So you cannot send more than 300. You cannot send more than 200. But for demand, like Mobile, maybe if you send 75 is okay. So, or you can have a constant exactly 70, or you can say at least 70. But you want to fulfill those demands. Yeah, that's it. So let's look at the solution that I posted for you. I know the formulation looks a little weird. Later, I show you lingo looks much easier than this. Huh? Yes, I posted. I posted like half an hour ago, so let me check it. Is it there? Okay. So on the left side, just put each link and the cost associated to each link. The blue cells are my decision variables, how many cars I would send on each link, which the Excel solver should solve the blue cells. Let's check the yellow ones. So yellow ones is just talk about each like city or point. For example, Newark happens in the two link of New York to Boston, New York to Richmond. Since it's just going out, the sign is minus, means you're just losing. And you look at the yellow cell. I'll just say the minus times associated number of cars. So those -1 times the associated blue cells, it just means how many you sent out. Let's look at Boston. So Boston happened on two links, one New York to Boston, another one Boston to Columbus. From Boston to Columbus, you send out, so the sign is minus. From New York to Boston, Boston receives cars, so the sign is positive. And also the associated yellow said just those arrows times to the blue cells, those +1 and -1 times to the blue associated blue cells that has decision variables. And same for other cities. So what we try to do in this Excel, just put all the links and dots somehow together and make the relationship that you already saw in the figure. But again, it might be a little challenging, but no worries. Later, when we go to lingo, it's much easier than what you see now. I'm just trying you guys to have some skills on being able to solve with Excel solver. Because it's one skill that might be needed later. So just keep in mind for linear programming, you try to formulate the relationship that you see in the problem. Okay, let's focus on the yellow cells. So the yellow cells should be the absolute value of yellow cell. Let's compare the absolute value of the yellow cells with the next row. So next row is -200. And if you look at the arrow sign, it's -1, -1. So whatever would sit in that cell should be greater than -200, or the absolute value should be less than 200, because you cannot send more than 200 cars. So what about 100? This is the Boston demand. So whatever happened to that yellow cell should be more than 100. Huh? It should be. It cannot be less than 100. So we don't know what happens on the yellow cell, because the yellow cell just those plus and minus times to the decision variable. It just means how many cars come in and out. And same for the other points. So basically, at the end, the only thing matters is these yellow cells and blue cells, because blue cell just means your decision variable. And based on your decision variables that you make, you end up knowing how many cars you have on each node or each city. Also, we have objective function. It just decision variables, the blue cell times the cost, their unit cost, which is under cars column. So any question about the formulation? I know it might be a little ambiguous or difficult, and it somehow needs some creativity. So how to associate those decision variable cities and link together. But again, no worries. This is just, I want to show you there is such a skills that might be needed later. Later, I promise you, when I show you how to solve through Lingo, you don't need those creativity. It's much straightforward. It's just pure creativity. So yeah, I know. And maybe you solved this transportation problem in a better way. So it's not that much. I know you might say how you end up knowing that or finding those kind of connection between like nodes and links and nodes, but yeah, it's just pure creativity. Let's look at the solver. So the formulation that I put there. Data solver. So first of all, I said my objective function is J20. It just decision variable number of cars to the cost of the link is a minimization problem. Also, I identified my decision variable, which are on those blue cells. The only constraint that I have, the yellow cells should be more than the next line, because you cannot put minus 300 for new art. If I said it should be more. So what if it's more means absolute value less than 200. So you can put minus 100, minus 150, but you cannot put minus 300. And same for the other points. So for demand points, like for 160, 170, 70, you should provide more than what they need. And again, it's just policy. You might want to exactly provide what they need. But based on the arbitrary policy that I have here, I just want to have at least the amount that they need. Okay, let's hit solve. Answer sensitivity. So as you see, that you don't send any car from Columbus to Atlanta, nothing from Atlanta to Richmond, Atlanta mobile to Atlanta, Jacksonville to Richmond. These are the zeros. Some of them has reduced costs. It just means how you can improve the transportation cost, so it makes efficient to use those links. For example, so for the Atlanta is 0. Let's look at Atlanta. Yes, so number 1, 2, 3, 4. This one. Sometimes it doesn't make sense. For some of them, it just means provide subsidy, but it just means how you can invest in some links, maybe provide some subsidy. That makes sense, those links to be included. For example, reduced cost of Atlanta, number for Columbus to Atlanta is 75. It just means, but the cost is just 35. It just means even you should pay something that makes that link feasible. So this helps you to think about the policies, how you can invest in some or provide some special policies some points to be included. For example, let's say maybe Columbus, maybe Columbus to Atlanta. So here doesn't make sense, but somehow, let's say you have a poor city that you want to just let transportation goes in. So you should think of what's the most efficient way of subsidizing, so you can have some business going on there. Which one you're talking about?
In the next sheet.
This one?
No. The problem one. The Columbus to Atlanta, we have 0 cars. Is that a fixed cost?
No, 0 is number of cars.
Yeah, so there are 0 cars. It's receiving.
Means you don't send anything from Columbus to Atlanta. So that link doesn't work because it's not economical.
Okay.
Huh? Yeah, there is a cost. Yeah, there is a cost, but as I said, the cost is so high. Maybe 35 doesn't look bad, but when you just make that complex network, it's somehow high. It doesn't worth even touch that link.
So they don't make the trip from Cologne to
yes.
It's not worth it.
Yeah, let's say there's I think 6. Let's say I said there's 7 cities. Let's say there's 7 cities for enterprise company. They never sent anything from Columbus to Atlanta.
Send a lot of cars to another. They have other locations as well, and they said it's not worth it to send cars to this location, so we could just send it to somewhere else. It was much cheaper to send it to another location, and then if they need it from that location, they could send it to the location.
Yeah, I see. So
that's why they would just make because it was much worth it.
Yeah, I'm glad you had similar experiences, so it makes more sense for you. But again, if next time you get hired for that position, you can formulate your Excel and show them objective measure. So say, okay, this is how much it would cost if you change this road. This is the associated shadow price, and you can just and again, if you end up working those transportation companies or supply chain companies, I recommend to take some operation research course. So you go more in depth of those shadow price, reduced cost, and those kind of things. So I didn't go that much in depth because the goal is just interpreting the results. But again, if you get hired in those companies, I recommend to take 1 or 2 operation research courses. That's really useful. So if you take those courses, those value here, it makes much more sense for you guys. Okay, good. So let's look at the second transportation problem. So we have a network of cities. You have to travel from Birmingham or Beeham to Virginia Beach. Your task is to follow the shortest time path. Time, direction, and scenic ratings are given. Here we only focus on time. Build an LP or linear programming model of shortest path. So you want to go from Birmingham or Beeham to Virginia Beach, and there's several options that you can take. So we want to minimize the transportation time. I give you 1 or 2 minutes to think about the problem. So what do you think about decision variables? What you should decide? Shortest is the objective, it's the goal, but yeah, exactly. Where do you want to go? So do you pick a specific link or not? For example, here you have two options. If you get to Atlanta, you have two here. Two. So it's just not too many things. So if you go to Charlotte, Jacksonville, or I don't know, Aville, whatever. So you have two other options. So you decide if you pick a link or not. So let's say you get to G-borough in the middle. So if you get to the middle, any point in the middle, you should get out of that middle, that point. So it just means you have a constraint for all middle points that when you go in, you should go out. So you cannot come to Gville and stuck here. You should go out. If you come to Atlanta, you should go out. So if you in, you should have an out. But for BHAM, you just go out. For VA Beach, you should just go in. So let's just formulate it through Excel. Problem 2. So still we have, on the left side, we have the link addresses from where to where. So we have the time coefficients. Also, we have a blue cells. The blue cells just means they're just either 0 or 1, if you select or not to select. For each city, like for example, Birmingham or BHAM, you just have negative ones, because if you are in Birmingham, you should go out. For, let's say, for Aville, you have 3 plus 1 and 2 minus 1, because you can get into that city with 3 different roads, and with 2 different roads you can go out of the city. So here I put the complete name. So 3 plus 1, because you can get inside in 3 different ways. You can go out of that city in 2 different ways. 3 ways in, 2 ways out. Also, my objective function is just time coefficient times the blue cells, which are just minus or plus, plus 1 or 0. It just means either you select that road with that time or not. If you look at the yellow cells, it's just multiplication of the route selection. The blue cell just 0, 1 times the direction. So, for example, Birmingham, either D6 or D7 could be 1, not both of them, because you just pick one of them. Let's go to the solver. So still objective function is same. Minimization, basically my decision variable just blue cells, and the yellow cells and next row are exactly equal. So what does the first yellow one, if it should equal -1, just means my only option just going out. For Atlanta is 0, so it's just saying you should, one of the -1s should have coefficient, has the decision variable of 1, and one of the plus 1 should decision variable of 1, 1 minus 1 plus 1, 0. Yes. So yeah, let me show you on the board. Atlanta. So for each inward links, we have -1. For outward link, we have, sorry, for inward +1, for outward -1. I said that, so we also have some decision variables. So for example, for Atlanta, times those blue cells. So either 0 or 1, which is the blue cell here, 0 or 1. Okay, so my constraint, if you look at the solver, let me show the solver again. It just said blue cells of Atlanta, this side, the yellow cell, and this 0 should be equal. So to have this one 0, one of these blues should be selected, and one of them should be selected. So let's say if this link is selected, 1 times 1, and let's say this one gets selected, 1 times -1. So here you have +1, -1 equals 0. So if you have this condition, it means you should come in and out. The second option, the second way that you have 0, you don't select any of them. If you don't come in, for sure you shouldn't go out. So either both of you have +1 -1, or you have 0 -3. In this one means you came in and went out. This one just means you never select Atlanta. Maybe if both of them are 0, yeah, you guys at home cannot see what how I show them. So if both of them 0 on the board, means instead of Atlanta 0 in 0 out. Oh, for Atlanta, I think I made a mistake. It should be different, but I think you got the point. Yeah. So if it's 0, means you go to Charlotte, or if you came to Atlanta, you went out. So let me fix it then. So you just have one internal link, one inward. Yeah. So means if you select Atlanta, for sure you should go. If you don't select, you don't go. Maybe it looks obvious, but we should formulate it. So the people who are using Zoom, could you guys see the board through the all? Because we have a like extra camera. I'm not sure. Could you be able to see me? None of them answer. I'm not sure even if they hear. Let's say, yeah. So they could see the board. So hopefully. So you got the point. This constraint just means you either never come in, never come out, or if you come in, you should go out. Otherwise, 0 never equals 0. So let's solve it. I don't go to the sensitivity this time but just keep in mind in your final exam, I ask you about those shadow price and basically reduce cost, how much you can basically deduct or change the constraint. So in the previous class, we had extended examples, but these are basically your final exam. But just keep in mind from next Wednesday, I went back to visualization and we start learning Power BI. So again, the way that I teach you Power BI, you have so many challenges and you learn through challenges like linear programming here. So the way that you learn, we have several types of problems, and through the problems you learn how to formulate it. Similar happens for for Power BI. I give you problems and the solution. So you learn through the problems. Because of the feedback I got from you, it seems that's more interesting. So the other option, I should tell you, this is this icon, or this is the, if you click on here, you get this. But I think if you learn through challenges, might be better. And you learn the solution, basically how to solve those type of problems. Assignment 8. I haven't posted yet. Is it your course? Yeah. Assignment 7. Oh, sorry. Here. Yeah, I got it. Sorry. Yeah, it's like a 9 problem. So I think your previous assignment, I didn't ask you to make a 9. I just said if you can even draw on the piece of paper, but here you should have actual 9 and be able to solve the problem. Okay. Let's look at the last problem. Make sure you travel through Elberg. Where is Elberg? Here, top. So this is Elberg. So what does it mean that you should go through that link, through that city? Sorry. So Elberg. Yeah, this is the previous problem. If you go in, you should go out. Or if you never go in, you never go out. No. Your final destination is Virginia Beach. But your policy is you should go through that Elberg. You're very close to answer, actually. So your friends say you should have +1 and -1. Is actually answer. Let's just clap for you. This is the answer, actually. So your friends said, to be sure that we go through Elberg, we should have both +1 and -1. So in the previous problem, we had +1 and -1. But we look at it in the way that the summation should be 0. One way of having summation 0, you have 0 in, 0 out. But here, we won't have in and out. So you either said the summation of inward links should be 1, just when you select one of them, or the outward link should be 1. Both of them are same. So on top of the previous condition, which the summation should be 0, we are not sure summation 0 means both of them are 0, or we have -1 and +1. We just add extra condition that summation of inward should be 1. So those three links are either 0 or 1. Summation 1 means one of them should be 1. So if you look at the solution that I posted, I had an extra yellow cell. This yellow cell is Knoxville to Elberg, Asheville to, Lynchburg, Asheville to Lynchburg, and also Greensboro to Lynchburg. My new constraint, it just said summation of all of them should be 1. Summation of all of them is F26. I can just focus on the outward thing. That's okay too. I think focus on outward is easier because you don't have to have summations. But here I just want to be just play around it. But so let me see. 9. I mean, I don't understand. What do you mean 9? Oh, okay. Workflow 9? Okay. Yeah. Oh, okay. Got it. Okay, so we look at like 2 types of problems, transportation problem. One left next class. So next class, I teach you a little bit of lingo, so that makes your life much more easier. Let's look at another type of problem, which is scheduling. Look at the second Word document. As a manager of a call center, you have to make sure that on each day, a minimum number of workers are recorded as listed in the table below. So Sunday through Saturday, so in each days you need different amount of workers. So they already have some idea of how much work they have. So they said because of different workload, we need different amount of workers. Also, because of their work and type of the day, they have different salary compensation. So each workers can be given 1 out of 7 plans available with 2 days off. Your objectives. There's a typo here. So your objective is to minimize the cost and make the decision that how many times each plan will be assigned. Yeah, give you a few minutes to think about that, then I get to a solution. So I think the decision variable is given. How many plans you should be picked. So for example, like, and also your constraint is also very straightforward. You have different amount of workers on each day. So an objective function, I think, is also very straightforward. You need to minimize the cost. So having said that, open the second Excel file. Okay, so as you see, I put those 7 plans. In some of, and also on the columns you have workdays. Again, this is out of creativity. So you may use different configuration of the tables that associate those constraints with those decision variables. But anyway, so 0 means no work days, 1 means work days. And blue cells are decision variables. So how many of those plans should be selected? So let me change this color to yellow. So each of them means how many days, how many Sunday workers comes from different plans, times of how many of those plans are selected. For example, if you for you select 2 for plan 2, 3, 5, and none from the rest. So the blue associated blue cells or decision variable 0, you just have 5 workers on Sunday. Because just 2 from, 3 from other, but you should at least have 18. So it's not acceptable because you don't follow the constraint. Same for Monday, Tuesday, up to the Saturday. So the yellow just shows how many workers you have on that specific day, given the decision variables that you have. Objective function, the objective function or total cost is very straightforward. The cost of those plans times of how many of those plans are selected. Let me go to the solver. So first of all, objective function is M18, just multiplication of cost times decision variable. My decision variables are L7 to L13. I'm trying to find how many plans I need. I know that those yellow cells, E14 to K14 should be greater than E15 to K15. Because I should have at least those number of employees on each day. The last but not least constraint is just having those decision variables to be integer, because it doesn't make sense if you have half a person or half a plan for certain days. So let's solve. Just keep in mind, when one of your constraints is integer, you don't have sensitivity analysis. So sensitivity analysis is just for continuous variables. So you never pick the plan 4. It seems the most favorite is plan 7, which is kind of intuitive because it's the cheapest one. You have different results. So what is your final cost? Is it different too?
30,600.
Is it the same for you guys?
No, I have the same answer.
You have same?
Yeah.
Could you solve? Do you get same?
Okay.
So let me check your friend's phone. Maybe just randomly click that or change some.
Yeah.
Oh, last I haven't. It was just a, and I mean, again, last class, similar to you, one of the constraints, I just randomly just click the keyboard. So last class, I got the wrong answer. I had to solve and put the actual video. It was you got the mistake, right? Or it was your friend? It was not you. Okay. Yeah, one of your friends got the problem. So I resolved the typo and just put the actual solution on Moodle. But yeah, I mean, your friend just randomly hit 0 here for some reason. So when he wanted to solve it, anyway, the answer was different. But I think I already covered too many problems. I think it could be very confusing. I keep adding. So let's finish for today. I'm going to post an assignment for you guys tonight. It's from one of the previous type of problems that we reviewed. We have still 1 week. Next week I start teaching Lingo. And hopefully from next Wednesday, we get back to visualizations again. And we start to do Power BI. Just keep in mind, I posted a video how to install Power BI, but I think it's very easy. You just Google how to install Power BI, but might be a little challenging, but shouldn't be too difficult. Oh, so you had difficulty in Power BI? You couldn't? Okay, if you couldn't use Power BI, it's actually is not good. You don't lose any credit in my class for that. But just keep in mind, in job market, it brings advantages. So try to work how to have Power BI and Mac. So it's even whenever you go around the world. So if you have extra skills, it's better. But let's see, if I give you assignment, you can do something similar in Tableau, and you don't lose any credit. But just Google how to have Power BI in Mac. Sorry, I don't have Mac. I don't know how to help you, but maybe talk with the help desk. Also, talk with the help desk. Help desk. See if they can help you to have Power BI and Mac.
I have Google before in the beginning of the semester.
And
I was trying to figure it out, but maybe I need to buy like a Windows computer later on.
I don't want you to spend too much in the class, but I mean, this is a skill. Maybe could you borrow your friend's PC?
My roommate has a PC.
Yeah, I mean, it's your skill even.
Any for
homework, I can do that almost through the net.
So no, because they have licensing issue. Yeah, so we don't have it on the lab, unfortunately.
So I need to go like license.
No, in the lab we don't have. We should have a license, but on your PC you can have it free.
Oh.
It's what they told me. It doesn't make sense to me, but yeah, the school told me for the lab they need to have a special license that we don't at this point. But if you can have it free on your PC, but still, I recommend to get a PC for that part because I think knowing Power BI is good for job market.
Rather than having?
Is an extra thing. So let's say you want to pay somebody to hire, and somebody just knows Tableau, and the one knows Tableau and Power BI. So he or she has something extra, you know.
It helps. Like let's say you're doing like Google Analytics certificate, for example, like that's a plus. Power BI, plus.
But you don't lose any credit in my class. So yeah, even if I give you assignments, you can do it in Tableau. Yeah. Cool. Could you be able to? You guys have it on? But what if could you install Windows on Mac?
I can, but I do want
It just destroy. Yeah, I think we have some discussion with some of you, including you. So.
I don't have other PCs use Power BI.
Yeah, this is just some skills. Even Solver may not good for the job market right now, but I'm pretty sure later if you get into a like supply chain companies or transportation companies like Uber, Amazon, Walmart, you should know something in Solver. You should know operation research, linear programming. It may not use good. The thing that I'm teaching this week and next Monday may not be good for your hiring, but long term in the company, you definitely needs it. I think Power BI or Tableau, it's just good for you to get into a job. So if you have some extra skills, that's better. Okay, so let's end for today. I think you already have like 3-4 types of problems. If you can find some way that you could bring a PC for the class, even 1, 2, or 3 sessions, or later try to do LinkedIn Learning and you get the certificate on your LinkedIn account, that's even better. But this is a skill that I'd like you guys to have some experiences with that. Okay, that's for tonight. Thank you very much. Take care and just keep posted. You might see an assignment. Have a great evening. Bye.